I want you to do something for a second. Look at your hand. Look at the skin, the veins underneath, the cells that make it up. Billions of them, all descended from a single fertilized egg, all running the same genetic code and molecular machinery. Now ask yourself this: where did that machinery come from? We usually say, Earth. Life began here, in ancient oceans, around 4 billion years ago. But a landmark study from 2026 is quietly forcing scientists to take a different answer seriously. What if it started on Mars? What if an asteroid slammed into a young, wet, living Mars, blasting debris into space, and a microbe survived the journey to Earth? What if you and every living thing are the descendants of Martian life? A team from Johns Hopkins University just tested this. The idea that life could travel between worlds is called Panspermia. It's older than you might think, proposed by the Greek philosopher Anaxagoras. Later, Sir Fred Hoyle suggested comets and interstellar dust could carry organic material across vast distances. For a long time, it was considered fringe. But then scientists discovered organisms on Earth that survive conditions that should kill everything. Extremophiles in deep sea vents and frozen tundra. The specific flavor we're talking about is lithopanspermia. Could life survive inside a quad meteorite ejected from one planet and landing on another? Mars and Earth are the perfect pair. Early Mars had liquid water. Rocks absolutely flew between them. We have Martian meteorites in labs today. A team led by K.T. Ramesh designed an experiment to simulate the violent shockwave of an asteroid impact using a high-speed gas gun. They sandwiched bacteria between metal plates and fired at speeds of 500 kilometers per hour, simulating pressures millions of times greater than our atmosphere. The bacteria proved hard to kill. 60% survived at 2.4 gigapascals. A microbe nestled deep in a boulder could easily survive a Martian impact. Lead author Lily Zhao said, "We have shown that it is possible for life to move between planets. Maybe we're Martians." Meet the star of the experiment, Deinococcus radiodurans, nicknamed Conan the Bacterium. It's one of the most radiation-resistant organisms ever discovered. It thrives in the Atacama Desert, survives extreme cold, and can handle the vacuum of space. It can even repair its own DNA. We don't have to imagine rocks traveling from Mars. We have ALH 84001, a chunk of Martian crust found in Antarctica in 1984. In 1996, NASA announced they found microscopic fossils inside it. While controversial, it proved Martian rocks reach Earth without overheating. Scientists believe Mars once had oceans and a thicker atmosphere. The Perseverance rover is currently exploring Jezero Crater, an ancient lakebed. Mars became habitable before Earth did. It cooled faster. Life may have begun there first and arrived here pre-made. If it happened here, it's likely happening elsewhere. The 5 letters of DNA were recently found in material from the asteroid Ryugu. We might be the descendants of interplanetary refugees. Look at your hand again. The science of proving our origins is more alive than ever. Drop a comment with one word. Your first thought hearing, maybe we're Martians. Subscribe for more real science. See you then.